Hey Chemistry, Mrs. KJ here, going over lesson 8.03, ions. Atoms of the same element always have the same number of protons. So a little bit of review in the beginning. The number of blank starts out the same as the number of protons because the atom is electronically neutral. So when we start, the number of protons equals the number of electrons. And that, again, when the protons equal the electrons, makes our atom electronically neutral. Blank can be gained or shared to make the atom stable. Electrons again. How do we find the number of neutrons in an atom? So we did a little bit of review about protons and electrons. How do we find the number of neutrons? Well, maybe I should back up and ask you this. How do you find the number of protons? The number of protons is the same as the what? Atomic number on the periodic table. And when we start, as I already said, the number of electrons equal the number of protons. So now let's go ahead and say, how do we find the number of neutrons in an atom? So it's the mass number minus the atomic number equals the amount of neutrons, or like I said before, the amount of protons is the same as the atomic number, so we can take the mass number minus the amount of protons equals the amount of neutrons. The reason the mass is only made up of protons and neutrons is because each proton and each neutron weighs how much? 1 AMU. And how much does every electron weigh? Basically 0. And for our purposes, we say 0, so because they don't weigh anything, we don't care about them when it comes to the mass number. All right, so let's look at the example I gave here. Here's our symbol, B for boron. I have the number 5, the number 10.81. Which one of these numbers is the atomic number? Which one is the mass number? And the atomic number is always the small number, and it's always a whole number. So here's our atomic number, here's our atomic mass number. So for boron, we have 5 protons. We said the number of protons and electrons are the same when we start out because it is electronically neutral. And therefore we have 5 electrons. And how many neutrons do we have? Well, remember, we need to round this to the nearest whole number. So 10.81 rounds to 11. 11 is the total mass, or how much the whole atom weighs. And 5 of that 11 is the proton's weight. So what's left over? 6, which means that we have 6 neutrons. All right, time to practice. We want to practice now so it's fast and easy for the rest of the year. So let's just look at nitrogen first. What's the mass number? And like always, when I ask you questions, you should be hitting that pause button and answering it yourself. What's the atomic number? How many protons are there? How many electrons are there? And how many neutrons are there? So answers for the top row. The mass number is the bigger number. We round it to a whole number. So we just say 14. The atomic number is 7. That's given up here. It's the smaller number and the whole number. The number of protons equals the atomic number. The number of electrons starts out by equaling the number of protons. And how did I get my number of neutrons? I took my mass number minus how many protons I had equals the number of neutrons. In this case, the number of neutrons is the same as the protons and electrons. Sometimes that happens, sometimes it doesn't. All right, go through, hit the pause button, and for phosphorus, what's the mass number? The atomic number. Number of protons. Number of electrons. Number of neutrons. And the answers are, the mass number is 30.97. We round that to the nearest whole number. So does it round up to 31 or stay at 30? It rounds up to 31. The atomic number tells us the number of protons, which is the same as the number of electrons. And how did I get the number of neutrons? I took 31, my total mass, minus the mass of all my protons, 15, equals the fact that I have 16 neutrons. All right, go ahead and do arsenic. What's the mass number? Atomic number. How many protons? How many electrons? How many neutrons? And in case you didn't know, the hashtag actually means number of, so I use it all the time. But I figured I better tell you that I'm not using it as hashtagging because I'm not planning on tweeting this out. Although I know it's just the most exciting recording you've heard all day. It means number of. All right, so let's look at our answers for arsenic. And the mass was 74.9, so it rounds up to 75. The atomic number is 33, which tells me I have 33 protons. Starts out the same number of electrons, which is 33. And then to get my number of neutrons, I take my total mass minus the number of protons, gives me the leftover mass, which is also my number of neutrons. All right, so let's get to the key vocab word here in the title. It says ions. Ions are atoms with a charge. What has to happen for atoms to have a charge? In other words, they are no longer electronically neutral. They now have a charge. They are either positive or negative. How does that happen? So again, electronically neutral. Let's look at that first. Electronically neutral means the overall charge is 0. So the number of protons has to equal the number of electrons, just like those tables we just filled out. For an atom to have a net, or total overall charge, that means it has to have more or less electrons than protons. So specifically, how does this happen? Electrons are gained or lost. The number of protons never changes until we get to nuclear chemistry, which is next semester. So for now, the number of protons never ever changes. How do you know if an atom will gain or lose electrons? How do you know how many electrons will be gained or how many electrons will be lost? Very, very, very important for the next 4 chapters to know the answers to these 2 questions. So, atoms want A to B. Atoms want a full outer shell to be stable. Atoms can get a full outer shell and be stable by gaining or losing their outer electrons. What is the vocab word for outer electrons? So I'm pointing to my outer electrons here in boron. My 3 outer electrons are called what? Valence electrons. Those are important. The valence electrons are going to be gained or lost in order to get a full outer shell, in order to be stable. Atoms want a full outer shell to be stable. That's why chemistry happens. Atoms can get a full outer shell and be stable by gaining or losing their valence or outer electrons. We need to know how many electrons it takes to fill up each orbital. All right, so it takes how many electrons to fill the first orbital? This orbital must be full before a second orbital is drawn. So the first orbital holds 2 electrons, a maximum of 2 electrons. Orbitals 2, 3, and 4, so when we keep drawing more and more orbitals, they can each hold a maximum of how many electrons? The first one holds 2, the other ones all hold 8 electrons. Now there's a little asterisk, here's why. Technically not quite true, but it's the best way to start learning chemistry. It's the best way to model atoms. If you take chemistry in college, you'll learn that there are actually different types of orbitals. Some, they call them spheres, peanuts, daisies, flowers. You do not need to worry about them for now. Bohr diagrams is the best way to start learning, even though, like I said, it's not 100% accurate. It works for everything we need. And that's how almost every single chemistry class starts out. So don't feel like, oh, Mrs. KJ just isn't teaching us right. No, everyone starts out with Bohr diagrams, and then you get more advanced later. All right, so speaking of, I just said it. What kind of diagrams are these? Where the first orbital holds 2 electrons, other orbitals hold 8 electrons, and you must fill an orbital before starting a new orbital. Those are called Bohr diagrams. All right, let's put this together. Sulfur has how many protons? Well, I have 16 and 32.07. So how many protons? 16. How many electrons? When it starts out, the protons and electrons are equal or the same. So I have 16 electrons. How many neutrons? 32.07. Is it going to round up to 33 or round down to 32? Think about money. If you have $32.07, you almost have $32. So 32 minus 16 equals 16. In this case, the number of neutrons is the same as the protons and electrons. That's okay. Sometimes that happens for atoms, sometimes it doesn't. Now draw the Bohr diagram of sulfur. Okay, so what goes in the middle? In the middle is our nucleus, right? And what is inside the nucleus? We have protons, which are positive, and we have neutrons, and neutrons, of course, have no charge. And so that is why you'll see I'm putting it as a superscript. A lot of times it's n to the 0 power. All right, so that's our nucleus. That's in the center. We have our 16 protons and our 16 neutrons. But now we want to add in some electrons. So I'll draw an orbital first. All right, so I'm drawing my orbital here. And how many electrons can fit in the first orbital? Well, the first orbital is pretty tiny, so it can only fit 2. So now that my first orbital is filled, I need to draw a second orbital. And I'll start putting electrons in. Now, how many total electrons can fit in the second orbital? Well, I can get a total of 8. And so we draw them around the clock. Because they're negative, they want to be spread out. And then what happens, it's actually pretty cool, they flip their spin. Or in other words, one of them kind of starts going backwards. So that's how they're able to pair up. So that's why you will see them drawn in pairs. It's also a lot easier to count them if you draw them nice and neat in pairs. All right. So how many total electrons have I drawn so far? 2 plus 8 is 10. How many total electrons do we have? 16 protons. We start out with 16 electrons. So 16. So I have a total of 10, 11, 12, 13, 14, 15, and 16. So there is your Bohr diagram of sulfur. All right, so our Bohr diagram of sulfur. So just another example, 16 pluses, what does that stand for? 16 protons. 16 zeros, what does that stand for? 16 neutrons, and of course, 16 negative electrons, all in the orbital. So let's get to the main idea of this. Bohr diagram of sulfur, will sulfur gain or lose electrons to get a full outer shell? And how many? Well, let's think about it. How many total electrons can go in this outer shell? That outer shell can hold 8, so that tells me that I have 2 empty spots. So in order to get a full outer shell and be stable, sulfur is going to gain how many electrons? It's going to gain 2. It's a lot easier to gain 2 than try and lose 6. Why? 2 is less than 6. That's all there is to it. Atoms are lazy. They want to do what's easiest. So sulfur will gain 2 electrons to get a full outer shell and be stable. Because this atom gained electrons, it is now what? What would be the vocab word? It'd be an ion, because now it has a charge. All right, so we're going to get back to the exact charge in the next video. So be sure to start that one.